Okay, we're going to go ahead and take a look at some of these problems. I kind of try and explain some of the ideas as we go through. So this is some of the ideas of like probability problems you'll see. So first question has Canada has two official languages, English and French. Choose a Canadian at random and ask what is your mother tongue. And then what we have here is we have our table that fills in English, 63% of them, French, 22%, Asia Pacific, about 6%, and then other. So what is the probability that you replace other? Well, we know that all of these have to add up to 1 for it to be a valid probability model. So if I do 0.63 plus 0.22 plus 0.06, what I'm going to get is 63 and 22 is 85. 85 and 6 gives me 91. So the other is going to be the complement to that. It's going to be 1 minus 0.91. It's going to be 0.09. So that's that question mark is going to be 0.09. Again, showing work, you'd want to show this and you'd want to show this for that. What is the probability that Canadians' mother tongue is not English? So again, this is saying what is the probability of not English? So the one way you could do it is you could add up all of these, like 22 plus 6 plus, we know that this thing is going to be 0.09. Or the other way we can do it is we can do 1 minus the probability of English. That's what the complement means. It means taking out all the taking out the stuff you don't want. So in this case, 1 minus 0.63 gives me 0.37. So that would be, again, work. Again, the big part of work would be that right there, definitely showing that 1 minus 0.63. You don't necessarily have to show that, but if it helps you remember, do it. What is the probability that a Canadian mother tongue is a language other than English or French? So in this case, you're going to have what is the probability of not English or not French? That's going to be not English or not French. So basically what that is saying is these two here. So in this case, that's the probability of being Asia Pacific plus the probability of being other. That's 0.06 plus 0.09. That gives me 0.15. So there we go on that one. So now that's the first question, just kind of using a table, a little bit of a review. Now again, here's a two-way table. I'm going to do these problems right here, pause it, do it in chunks. So if we select from the school system at random, what is the probability that we choose a female? Well, my females here are 275 out of 595. So my probability of being a female is 275 out of 595. And notice it's a complete sentence. Probability of female equals 275 out of 595. Don't just put this down because, again, that's considered like incomplete sentence. So make sure you put that probability in front. This one's probability of eating breakfast regularly. So we're going to say probability of breakfast, or B for breakfast, either one. So in this case, if we eat breakfast regularly, it's these 300 people here out of the 595. Again, these are the marginal distributions. What is the probability of a female who eats breakfast regularly? Okay, and this is an and situation. This is saying that you're female who eats breakfast regularly. So in this case, it's these 110. So the probability of being female and breakfast is going to be 110 out of 595. Okay, this is an and. Just so you know, when you see something like this, you got to think of this almost like an and. Probability of female or someone who eats breakfast regularly. So that's saying female or breakfast. And that formula is on your formula sheet. It's taking all my females, taking all my breakfasts, subtracting my overlap, female and breakfast. So in this case, it's the 275 plus the 300 minus the 110. So that's what, 575, 575 minus 110 gives me 465. So that's going to be 465 out of 595. Okay, so there's our work there. Construct a Venn diagram, and we want to do breakfast and males. So okay, we'll do this big old box. So we'll do a circle for B, circle for M. So this is going to be breakfast. This is going to be male. So these are males who eat breakfast. So that's these 190 people. So that's 190 here. These are males who don't eat breakfast. So that's these 130 right here. These are people who eat breakfast who are not male. So my females who eat breakfast, 110. And these 165 would be outside. These are people who neither eat breakfast nor are male. So these are females who don't eat breakfast. Okay, now probability of B or M. So again, probability of B or M is equal to the probability of B plus the probability of M minus the probability of their overlap. So in this case, if we want to look at it, we're going to say, in this case, probability of B is going to be 110 out of 595. Probability of male is going to be 320 out of 595 minus the overlap of 190 over 595. So if I wanted to go ahead and do that, what I would do is it would be, when I add up all these, I'm going to get 430 out of 595. Okay, another way to think about it is basically you want to add up all these numbers. 110 plus 190 is 300, 300 plus 130. In this total circle, there are 430 people out of the 595 total. That's another way to say. And in this case, these are idea up here. It's like a male or someone who eats breakfast. Okay. Now this one, this is saying the probability of being not breakfast, not breakfast. That's the BC. BC is not breakfast. MC is not male. And it's saying the intersection. So again, it's saying where are you not breakfast? So if you think about it, you're not breakfast here and here. So you're not breakfast in the 130 or the 165. You're not male in the 110 and the 165. 110 and 165, you're not in the male circle. It's asking for the intersection of that. It's asking for these people right here. It's asking for the probability of being a female who doesn't eat breakfast. In this case, it's going to be 165 out of 595. So hopefully that helps. I'm going to do the next couple questions in a separate video so that we don't overload time.